Hello, good morning. Looks like there's two of you on. Um, Excuse me while I get used to talking again. I feel like over the weekend I don't do anything. Anyway, that's besides the point. So I wanted to just sort of update you because I'm sure you're sort of wondering, since the ACT got like postponed until after the school year is over, we kind of had it all planned to where we would be done by now, right? Because last week was supposed to be the ACT. So what I have decided for now, it might change, I guess, but what I've decided for now is to hello, good morning, is to go back and sort of review the topics that we had the hardest time with, and sort of just sort like solidify some really important aspects of the curriculum we did this year. So I don't know if you feel like you are struggling with a certain thing or you want to talk about a certain thing, I'm open to suggestions. For now, I'm just sort of going with what I feel like we need a better foundation in. So that's what this unit is going to be, and we'll see about next unit. I'm not sure. I don't know. We'll see. So that's my plan. We'll just get right into it. We're going to do actually what we did the very first lesson we did in this class. Because of how often it comes up on the ACT, I just feel like it's a really good thing to review. Speaking of the ACT, I forgot to also mention, please make sure you took that practice ACT that was assigned last week. That's super important, and it's going to be really big on your grade if you haven't taken it. Make sure you take it. I think it's still open. If not, just email me and I can fix that. Um, yeah. Anything else I was going to say? Oh, yeah. Also, I will put your grades in for that today. So just be looking out for that. Okay, so we're going to talk about linear equations again. So this is J-1. That's what letter we're on. Linear equations. Okay, so first thing to talk about with linear equations is just the form that you'll usually see. Felix, you'll be okay. You always say that, but you'll be okay. Um, what was I saying? Okay, yeah. The form that you'll mostly see is called slope-intercept form. And so bear with me, if this is review, I mean, it is review. We've done this before, and you've done this several times before you even met me. Um, but I promise it's going to be really relevant, especially on the ACT. So slope-intercept form, missed that word. There you go. Slope-intercept form is the one that you see all the time. It's y equals, and we're going to do colors here, mx plus b. And hopefully you remember that the n in this equation is the slope, and the b is the y-intercept. So something that I noticed when this last ACT and also when we did the homework for this lesson, is that graphs come up a lot, and so I wanted to just practice associating graphs with the equations. So we're gonna graph a couple of them, and then we'll talk a little bit more in depth about slope and such things. Slope is, again, just as a reminder, what we see often is this rise over run thing. And that is super helpful because when you're looking at an equation, okay, so for those of you concerned about the ACT that you just took, I think that's what you're talking about, Felix. I know that your percentages look really scary on those things, and that's because the ACT, I mean, the ACT is graded differently. It's not a percentage. And so I'm going to grade them like the ACT grades them, and then I'm going to curve them. So I promise that you don't have to worry about failing the class because of that. So I'm doing it the same way that we did when we took it in class. It's just that we didn't take it in class. So don't worry about it. Okay, so we're gonna just graph a couple of things. First, let's graph y equals 5x plus 1. And I'm going quickly because I know that this is something that you've seen a lot, but tell me to slow down if you want me to. I'm gonna have to make that graph bigger. And I know that because the slope is 5, which means following the rise over run pattern, you go up 5 over 1. So don't get freaked out when the slope is not a fraction. If it's just a normal number, it's over 1. That's the same. So like if you're dividing 5 by 1, you just get 5. Anything over 1 is the same thing as just that number. And so the slope in this case is going to be 5, and I'm just going to put it over 1 so we can sort of see that fraction rise over run thing happening. And the y-intercept in this one, I guess that's b in our equation, is 1. So you start with a y-intercept. You start with a y-intercept, so I'm going to start at 1, and then from there you use your rise over run. So you go up 5 over 1, up 5 over 1. 1, 2, 3, 4, 5. Oops, over 1. This is going over my graph. I told you I should have made it bigger. I'm also going to put a dot down here at down 5, back 1, just so I can get this line straight. Usually we're able to draw a graph with only 2 points, but on actual physical paper, it's kind of difficult. Yeah, so that's our graph. We're going to do 2 more. The second one is y equals 1/3 x minus 2. This one I don't need quite as big of a graph, thank goodness. Okay, again, you start with a y-intercept, which is -2 in this case, and the slope is up 1 over 3. So start with -2, you start down 2 on the y-axis, and then you go up 1 over 3, up 1 over 3. And I'm going to put one sort of the opposite direction as well so we can get the line straight. And there's our graph. Do I have room for another one? No. Lame. Yeah, I'm gonna have to start down. Okay, so the third one, we're gonna do y equals -2/3 x plus 2. So just as a sort of reminder, the slope always comes next to the x. Your slope is always multiplied by the x value. So that's what makes it the rate of change, or how something's changing. So on this one, we're starting at +2. My line is kind of ugly, but that's okay. And then a negative slope, this is -2/3. It means that we go down 2 over 3, down 2 over 3. So instead of being a rise, it's like fall down, because it's a negative. So we go down 2 over 3, down 2 over 3. And again, and then I'm going to do it backwards as well, which creates this line. There you go. Good. I'm gonna maybe zoom in. I know it's hard to see if you're on a phone. Okay, so the next thing we are going to talk about is just sort of identifying the slope, which I've been looking through ACT questions and that comes up quite a bit. It's just being able to identify the slope is something that will help you get the right answer. Even if the answer is more like, if it's like, write an equation for this, or which one matches. If you can match the slope and then check for x and y values, you'll be able to find the right answer. So I'm trying to give you like the best tools that relate to what you've already learned, or basically you have already learned this stuff. But I'm trying to give you all the tools you need to get the right answer, even when it's a complicated question. So I'm gonna turn the page, and I think I'm actually gonna get a lined piece of paper because I don't have anything graph on this part. Okay, so finding slope is our next bit. And we're first going to talk about just sort of what slope is. So the reason slope affects the graph the way that it does is because it represents how things are changing in the scenario. So slope is like the rise over run, which that helps us graph it, and it helps us get a slope from the graph. But that also means that rise over run means how much is x changing and how much is y changing. I just did the hand motions opposite for what I said. The y changing and the x changing, which makes this also a way to write slope. Those little triangles are a way to write change. It's called delta, that symbol is, and we often use it in science to mean how things are changing. And so because that's a weird symbol, I'm also going to write I'm going to write it out, how much y changes for each change in x. So it's the change, how much y is changing over how much x is changing, which helps us find the slope in sort of any situation. So the first scenario is when they give you 2 points, which doesn't always look like they just spit out 2 points. So I'm going to write down one of the sort of like a question you might see on the ACT. Carmen is making clay pots. At hour 4, she had made 10 pots. And at hour 8, she had made 15 pots. I don't know why she's making pots. Maybe it's to sell. I don't know. So the information that they're giving us actually is 2 points. It just doesn't feel like it. So Sage asked, what if the graph doesn't show all the numbers you need? So I think what you mean is, like if it doesn't have a y-intercept. Usually what I have to do when I'm graphing something and I can't see the y-intercept, or like the slope takes it off the page, is I have to make a little sketch and then see what part of the graph they're showing me. I don't know if that helps. If you encounter one of those, you should email me and I can help you. Because that does happen. Sometimes it doesn't show you the y-intercept when you're trying to find the y-intercept, which means that most of the time I just draw a little picture and I continue the graph until it hits the y-axis. and then see where it crosses. So that's my method, but there are other ways you can approach that as well. Maybe we'll do an example of that. So anyway, they're giving us 2 points, even though it doesn't feel like they're giving us 2 points. They said that at 4 hours, Carmen had made 10 pots. And at 8 hours, she had made 15 pots. So even though it doesn't look like points, they still are points. And we can look at how much time is changing, and then how much the pots are changing, the number of pots. So the hours have gone up 4, and the pots have gone up 5. And just as a reminder, I know I've said this, but x values most often are time in word problems. If there is a time factor involved, usually it's the x value. So you can almost always assume time is x and whatever the other thing is y. Because time tends to be the thing that doesn't change. I mean, it changes consistently. That's what I mean. It's the thing that's gonna go on no matter how many pots Carmen is making. Time still is gonna keep going. Which is why it's the independent axis, because it continues independent of anything else. So yeah, so time is our x value, and the pots that Carmen's made is the y values. So we just put that into our change in y over change in x kind of formula for our slope, and the change in y is 5 because she made 5 more pots in that time, and the change in x is 4, which gives us a slope of 5 over 4 in this equation. The next thing that they often do is give you a table, like so often. I don't know why they like tables a lot on the ACT. So our example table, it's not even gonna have a word problem. Usually they have word problems with them, but we don't really need it. If we have a table, you don't really need the word problem. So this one is gonna be time. Again, time is the input, and cost is going to be the output. For example, maybe this one's about like renting a bouncy house or something for a certain number of how much time, or a venue maybe for a party. So these are going to be in hours. Time is in hours, and cost is in dollars. So for 1 hour, it's $8. For 3 hours, it's $18. For 5 hours, it's 28. And for 7 hours, it's 38. So the thing that they often do on big tests like this is that they like to give you more information than you actually need to solve the problem. And tables, maybe that's why they like tables, because tables often give you more information than you actually need to solve the problem. Because if you notice, a table is basically like a collection of points. And we only ever need 2 points to get a slope and even a y-intercept. You only need 2 points. And so this table, for example, gives us 4 points. We only ever need 2 of them. So some of the trouble with big tests like the ACT is sort of differentiating what you need and what you don't need. Because sometimes more information is like, I don't know, it's confusing. So all we're looking at is how much the cost goes up for each jump in hours. So our hours on actually each of these points, but it doesn't matter, we're just looking at 2. The hours go up by 2. From 1 to 3, that's plus 2 hours. And then the cost goes up by 10. And so if we stick that into our change in y over change in x formula, change in y over change in x, I don't know what that was, change in x, our change in y, the y value again is the cost, because time is pretty much always the x value. So our time is going to go on the bottom, and that was our 2 plus 2, and our change in y goes on the top. So you might notice that this one actually reduces. 10 over 2 is 5. So our slope for this one is 5. So tables sometimes are a little bit of a misdirection. They're giving you too much information for, because it's the ACT. And you have to differentiate which information is important and which information is not. Next, we're going to do like an example where they might give you a graph. Again, the ACT questions are never going to be like, what is the slope in this graph? Because that's like too easy. But you can use these skills, like you're going to have to use, these are like tools in your toolbox. You're going to have to use like several of these often to figure out the answer to a question. Just remember to read carefully. Yeah, read carefully and use the tools you have. Don't give up when it just feels too hard. Because normally you have the tools that you need. So they might give you a graph. I'm just gonna sketch a graph really quick. The x-axis and the y-axis are just gonna be our variables for this one. And I'm not gonna be super specific about this because here's the deal. Okay. Sorry, I'm reading comments. Okay, so for this graph, let's say that this point is like, this is like 5, and this is like 8, and this is like 1, and this is like 3. So literally almost the same thing, except for it's a little bit more visual here because we can do the rise of a run thing, like reverse engineer the rise of a run. So the rise here, we're going from 5 to 8. So the rise is plus 3. I don't have anywhere to write that. Maybe if I zoom really close. Plus 3. Not really. There you go. So we're going up 3, and then over from 1 to 3 is 2. So we're going up 3 and over 2. So our rise over run, let's zoom out again. Rise over run, also known as the change in y over the change in x. The change in y values was 3, and the change in x values was 2. So that gives us a rise over run of 3 halves, 3 over 2. We're gonna do one more of these. And that is just when they give you sort of a word problem. And this is harder to give you a good example that will work for many cases because they often they say in any situation it could be different. But I'm going to give you some words to look out for. This is actually one of your questions on your homework. So William, I'm not going to give you the answer, but this is helping. William is running 100-kilometer race at an average speed of 14 kilometers per hour. Maybe. I don't know. So what we're looking for here is what the slope is in this word problem. So looking for slope in word problems like these is more about looking for a certain word association or just looking for how is it changing. In this situation, it's time versus how far William has gone. So anyway, so they're giving you this kilometers per hour as the speed, and speed is a rate of change. That is the slope. So when you see something like a speed or anything where you have units like kilometers per hour, inches per minute, miles per hour, cookies per person, like anything like that is usually an indication that that is slope. Uh, you just have to remember what slope is. Slope is how things are changing, how fast things are changing in relation to each other. Um, so if we're looking for, well, in this problem, let's just first write, in this problem, the slope is 14 kilometers per hour. Slope is 14 kilometers per hour. So some other words to look out for, if it helps you looking for the slope. We're going to preface this. Look for words like, often you will see the word per, or it will be sort of like this. In this problem, kilometers per hour, the way that we read that is that we say per because of that like slash, I guess. So often that will come up per something. They also often say like for every blank. For example, like which one would we use for every? Like, Jake makes 5 lollipops for every person in his family. Or maybe person that comes to his store. I don't know. I'm bad at making up word problems. They also often say each, like for each. Like the tickets cost that many dollars for each one. Or on this one, you could rephrase this question, actually, this scenario with William running, as if with each, you could say he runs 14 kilometers each hour, which would indicate that that is a rate of change. Yeah. I'm not sure what your question was about when you said why, Sage. The chat is like delayed, which is very annoying. I know, complicated word problems. I know. Which is why we're trying to like cover things now because it's helpful later. Anyway, so again, they're never going to be like, what is just giving you a word problem, and probably you're probably never going to see a question that just says what's the slope of this, but it will help you, like if it says what equation represents this scenario, you can look through the equations and find which one the slope, where the slope is correct, right? That will definitely narrow it down. And then we'll talk about how to sort of finish that process, how to like finish the rest of it, figure out what exactly the equation should look like. Okay. Okay, what we're gonna do next is talk about how to find, last thing, I promise. Actually, I'm gonna need another page. Seeing too many pages today. How to find x's oftentimes the questions on the ACT, no matter how like convoluted they sound, often they come down to either finding x values or finding y values or checking values. And so we're going to talk about how you do all 3 of those things. Oh goodness, I'm sorry. I meant to do y values first. We'll do x values in a second. Yeah. So finding y values, finding x values, or checking values. That's really how much it all comes down to, is being able to find these things. Um, so you also have to remember that functions operate on an input-output basis. The inputs are the x values, the y values are the outputs. And so in a question, in a word problem, you're looking for like the x values, which are usually like time or something that runs on independent of the other thing, um, as the input. That's the input. And then the output is like, okay, how much does it cost for that much time? Or how far have you gone in that much time? Um, so you'll see what I mean in a second. I'm not going to give you word problem examples, and we're going to talk about how to do it with equations and how to do it with graphs. Because usually they'll give you one of those two things, either an equation or a graph. So for finding y values, it's pretty easy because y values are the outputs, and so they will often say, they will often say like how much does it cost for 10 hours. So if the equation is something like, let's just say the equation is 15x plus 2, and they're saying how much for x equals 2, what does y equal? And all you have to do to find out what y is you take the x and you plug it in to the equation, because x is the input and you're looking for an output. And so let's write that. This is our input and this is our output. So you're gonna just write the equation like it already is, except for you replace the x with, oh no, 2, because that was our input. And then you solve that. So 15 times 2 is 30, plus 2 is 32. And that's our output. We just found a y value. If it's a graph, let's just say this is our graph here, and it starts at there and keeps going, and this is like 8, and this is like 105. All you're looking for the input-output relationship, if it's asking for how many paper cups a company or a machine produces in 8 hours, you go across the x-axis and find that value. We'll just write my fake word problem. How many paper cups a machine can the machine produce in 8 hours? Question mark. That's an example of like a question where they're looking for an output, because they're giving you an input value and you need to find the output. So from a graph, you go along the x-axis, find that input value, which is 8 in our silly little graph here, and then you follow that value up to find where the graph is at 8. And that value, the y value, is what they want. So they're essentially looking for like that point that we just identified is 8, 105. So they're giving you 8 and they're looking for 105. They're just looking for the other part of that point, the y value, which is not bad to look for on a graph. Okay, next we're going to talk about finding x values. again with an equation and a graph. So for finding x values, they're going to give you the y value and they're looking for the x value. So let me see if I can think of a word problem for this one because I want it to be more relevant, even though it's sometimes my word problems are interesting. Let's go with the paper cup thing again because I'm not creative today. So, so say like they give you an equation for how many paper cups the machine produces every hour. So like it produces 8 every hour and not 8, it should be way more than that. Let's say it's 80 per hour. And it starts with, they already have like 100 already created. And then their question will look something like, how long will it take for the machine, or maybe just the company, to have 260 paper cups. So you'll see something like how long or how many minutes or what it's going to be asking for is x values. It's looking for the input and it gives you the output it wants. So the process is very similar. Instead of replacing the x value, you're going to replace the y value. In this case, we're wondering how long will the company take to have 260 paper cups. So the 260 paper cups is a y value. So they're saying when y equals 260, what does x equal? So instead of getting an input and finding an output, we're getting an output and trying to look for an input. So we're going to replace y with 260, and it says equals 80x plus 100. So you'll notice that it's not as easy as just typing into a calculator or computing it really quickly in your head because this is an equation we have to solve. And we're solving for x. So that process hopefully is going to feel familiar. Something we do a lot. I'm going to take away 100 on both sides first, and that will give me 160 on this side. And now we still have 80x. And hopefully you've guessed next we would divide by 80 on both sides, and we would get 2 equals x. So the input required would be 2 hours worth of production would give you that many paper cups. So in a word problem, it's kind of the same, except for it just takes a little bit of solving. On a graph, it's very similar to what we did before, except for instead of going along the x-axis and looking for the value you're trying to find, hang on. So we're going to answer the same question, except for now we're going to pretend we don't have the equation, and we're just given the graph. So 160 cups takes how long? So instead of looking for the y value in this equation, they're looking for the x value. So we need to go along the y-axis and find 260, which we'll say is like right here. You go along the y-axis and find 260, and then you go to the graph. It's going to be either left or right. You're going to go find the graph and find out what point that is. What value of x gives you that 260? So on a graph, it means sort of following down, going and finding the graph, and then following that point down to what value it gives you, which apparently is 2 hours. My graph is really bad, but that's okay. The x-axis is just very stretched. There's one. There you go. So instead of going along the x-axis, finding that value and following that up to the graph, you're going to find the y value and follow it over to the graph and then find what x value gave you that y value. One more. Oh no, I ran out of room. I'm using a lot of pages today. Okay, I guess we'll get another piece of paper. And apparently it's graph paper, and that's okay. We're also going to talk about checking values. Now, what's really valuable about this skill is that if you, especially since the ACT is a multiple choice questions, they're multiple choice questions, you can use this to check each answer. If you have run out of other options, you can use this to check. Checking values is just making sure that it gives you a correct statement. That's all it is. So in an equation, if you're trying to make sure that, for example, 325, you're trying to see if those values, that x and y value, input-output pair, gives you a correct statement for the equation, which is y equals, to think for a second. Hang on. There you go. That works. So if your equation is y equals 5x plus 10, and you're trying to see if 325 works, you just replace the x and the y in the equation with your x and a y from your point and see if it works. So, and by works, I mean gives you a correct statement. So my y value in this case is 25. So I'm replacing my y with 25, and then I'm going to replace my x with 3 plus 10. And then you solve both sides of the equation. The one side of this one is already done. We know it's 25. The other side says 5 times 3 plus 10. 5 times 3 is 15, plus 10 is 25, which gives you a statement that says 25 is equal to 25, which is a true statement. So that means that point works in the equation. You might use this to double check your answer, or you might use it to check an equation. For example, if they give you a bunch of different equations that they're saying which of these equations represents this scenario, you can plug in values from the scenario to each of those equations and see which ones work. It's a really good tactic for when you're not sure what the answer might be or how to start from scratch and find an equation. You can always check an equation by checking values. The same goes for graphs. If they give you a bunch of different graphs and they're saying which one of these represents the scenario, you can check and make sure that the point that you're looking for is actually on the graph. So for example, if they're like, I don't know, is 45, 50 on this graph, you look for a point on that graph and see if it works. And if it's on the graph, if the point 45, 50 is on the graph, then it is. Then that works. Sometimes you have to check more than one point for equations to be double sure that it's right. Because sometimes two graphs can have one point in common, but they can't have 2 points in common without being exactly the same graph. So if you need to, check both, check 2 points, but that should be the most you ever need to check is 2. Yeah. So you have homework today. It's J-1 called linear equations. And I want you to read very carefully when you're doing your homework because most of this entire homework is ACT questions. Because this is such a commonly used topic on the ACT, there were tons to choose from. So most of it, if not all, is ACT questions. So I want you to read carefully. Like I said, most of it comes down to finding an X, finding a Y, finding an input, or finding an output, right? Finding X or finding Y or checking. Um, yeah, I know. We always talk about how quickly they think you can do this, and that's part of the challenge, but you don't have that limitation for your homework. So read carefully, and as you do it more, you get better at noticing when they're asking for an output or when they're asking for an input or when they're asking for checking for values. Um, so most of the time, checking values comes from like if they're trying to, if they're having you look for an equation that represents the scenario, or if they're looking for a graph that has it's representing the scenario accurately. Um, Inputs and outputs, they'll ask like what how far has William run in this many hours or that kind of thing. So just read carefully. I will have a study session in a couple of minutes, probably at 11. And please join me for that. I know there's only 6 of you here. We can easily have a study session with 6 people. So and as a bonus, you get help on your homework, right? So yeah. And I need to talk to people. I feel so awkward and weird. I don't know if this is the same for you, but the longer I stay home and like don't talk to people, like the weirder I get. Like I can't talk anymore. It's frustrating. So anyway, I would appreciate the company. So come hang out with me and I will help you with your homework. And then let's get it done now so you don't have to worry about math class until Wednesday. Of course, if you have conflicts, that's fine too. I will have a study session tomorrow if you are working on your homework tomorrow instead of today, just let me know and I'll invite you. So be watching for that. I would love to help you on your homework today. Again, this is like a super important and super common topic on the ACT. So it's important to get this down the best you can. It'll help you on a lot of the ACT. So it's a valuable skill to have. So, okay. Okay, I will hopefully see you in a minute then, and I'm gonna end the live stream and just be watching for the study session. Okay, bye.